Ahoy Rovers! In this week's episode, Andy Dize, the Naval Architect, will be joining me via Zoom to answer all the questions that you sent in over the last week concerning the building of the Wave Rover 6.50. Now, I also have some other news, which is the study plans are now available, and there'll be a link to those study plans in the video description. Now, normally, under normal circumstances, the funds from the sale of those study plans would go directly to the Naval Architect, and quite rightly so, because it compensates the Naval Architect for all the hard work that goes into completing these plans. However, in this case, Andy has very, very graciously agreed to let me sell the first 100 study plans on my site, and that money is basically a fundraiser to help purchase the fiberglass, the epoxy, and the other building materials. So let's give a great big Wave Rover cheer for Andy. Now, without any further ado, let's go via the miracle of Zoom, visit Andy. Good morning, Rovers. I've just initiated a Zoom conference with Andy Dize. Now, Andy Dize is the Naval Architect who is designing the Rover 6.50, the Wave Rover 6.50. We've decided to call it that because the length of this boat is 6.5 meters, which is 21 feet 4 inches. And that was one of the parameters I gave Andy in the very beginning of this relationship. I said, I'd like a boat that is, say, no bigger than 6.5 meters. That's where we're going to start. I also want the boat to be very well balanced and to track well so that it's going to be easy to optimize wind vane self-steering. And the third parameter I gave to Andy was, I want this boat to be easily buildable by the average backyard builder, and a backyard builder of modest financial means and someone with nothing more than a shed or a garage. I wanted this boat to be put the power back in the hands of the backyard builder to be able to build something economically and still get on the ocean without spending a lot of money on a high-tech rig or other gadgets that most small boats these days seem to really tack on. So that's where the relationship started. Now, I'm going to just pass it over to Andy right away and let Andy tell us just a little bit about his background. Go ahead, Andy.
Yeah. Hi, I'm Andy Dize. I'm working on this project with Alan as his naval architect. It's very interesting to work on a small boat, much more so than a larger boat. I'm a degreed naval architect with over 42 years of experience designing various types of boats. I've built boats. I'm a racing sailor with over 52 years of experience. I started very young, but it's been very interesting. And having the capability of understanding what a boat is, what a boat goes through, gives me as a naval architect a background that I think is perfect for the Wave Rover 6.50. Some of the boats I've designed have been large sailboats, small sailboats, power boats, done for commercial, private, and for military use.
A lot of you have written in questions through the comments section in the videos, and those have been great. And so I've compiled a lot of them and I paraphrased them into a few questions, and we're going to see if we can get Andy to tackle those and explain them. So The first question is, Andy, what is the type of construction? What's the method of construction we're going to use on this boat, and why is that so appropriate for backyard builders?
Yes. We are using a male mold type of construction, which consists of a variety of frames and a strong back. And what that means is a strong back is a structure that's being placed on the floor of the construction building, and then the frames will be set up at various locations to help define the shape of the hull. Between the frames will be longitudinals to support them to keep the shape, and then on top of that framing we'll be putting the marine plywood. and we'll be using marine plywood in this case for this boat for the hull, the deck, and the bulkheads. We're taking this approach because it's a very inexpensive and quick way to build. Process used by many backyard builders just to get a very good and clean shape. It also gives you a lot of capability and time to refine the design as well, for construction purposes. We are looking at using different materials. I know some of the questions came in, said, hey, how about using Divinycell or some other types of materials? We are looking at that in the future for some other of the other Wave Rovers, and looking at also licensing with various production builders.
All right. So now we're going to be using 9mm plywood, which is pretty standard for boats this size.
Yeah.
And 9mm plywood is the same as 3/8 plywood, marine grade. Now, how is something so thin strong enough to make a boat that's going to be possibly going anywhere on the ocean?
Yeah. 9mm ply is you call it thin, but it's fairly thick material, and it has a lot of given strength with it. But in the design of a boat, it's not only the surface material that helps keep the boat shape, but it's also the internal framing. The longitudinals, the framing, internal supports, they are all being located in the boat to suit and to support structurally the surface hull shape, the surface plywood. We're also adding a layer of fiberglass on the exterior of the hull to add additional strength. We're coating the chines with fiberglass tabbing to keep those in perfect alignment and strength. And the bottom of the keel, the bottom of the hull where the keels are being attached, is going to have 2 layers of 9mm plywood, as well as supports for the keel. So between the materials, the layout of the material, the construction details with fiberglass, it's going to provide a very light and very strong hull.
And see, that's where a naval architect comes in, because I can say I want a boat this size, but Andy then takes that and he does the engineering to make sure that that size is strong and capable of what we're talking about. And that brings me to the next question, because we're talking about making a boat and keeping it light for the purposes of needing really less sail area to drive that weight. So, Andy, what is the sail area / displacement ratio for the 650? And what is the coefficient or the number that's recommended for a cruising boat?
The current sail area displacement ratio for the design of the Wave Rover 650 is 17.1. This is slightly higher than an average for this type of boat, which is in the range of 15, which we'd like to see. But at 17.1, it still provides us a good, comfortable boat. The performance of the boat is affected by a number of things. You can increase the weight, decrease the weight, increase the sail area, decrease the sail area. This 17.1 ratio gives a good starting point to be able to provide an overall safe and comfortable cruising boat, which is what you were looking for, Alan. But it also allows you to carry sail area and get some performance out of it. So it's not a sluggish cruising boat. The goal is to make it very comfortable and easy to sail.
Absolutely. No, I'm very happy with that 17. The next question is, what is capsize ratio and what is Wave Rover's ratio? And most important to me, is she going to be self-righting?
Yes, the capsize ratio for the Wave Rover at the current moment is 2.2. The capsize ratio itself is an indication that's been used by a number of designers it's a theoretical determination of the safety of a boat. Most cases, people look at a factor of less than 2.0 providing you with that safety. But that's only an initial indication of the stability and capability of a boat. We all know that, and I know from many years of being on the water, that you do not want to capsize, and you can vary that capsize by your sail area. That's one of the factors that doesn't go into this calculation. So as the wind increases, you reduce sail area. But the other way to actually define the stability of a boat is by calculating its riding arm energy. This is a factor that's used in naval architecture design that comes from the definition of the hull form, the center of gravity of the boat, and it makes sure that you don't exceed the capability of the hull. Now, hulls have a very large range of angles, angle of heel. The more weight you put in it, which we're looking at putting weight in the keel, because it is keel and it helps the stability of the boat, that will offset the riding arm moment that's in the hull. So at the moment, I see 2.2 as being a very good number for the Wave Rover. Once we get into finishing up the final calcs for the design, we can determine where the ballast goes, and we can get us to a point where we're very, very, very safe.
So in short, will the boat right itself should she ever be in the unfortunate circumstance of being upside down?
Yes, it will. That's the beauty about sailboats. With the lower weight in the keel, that is a very big advantage. The other advantage we have is the shape of the upper sections of the cabin. They're actually insloped. So as you heel more with those insloped surfaces, you're losing water plane. That will help the boat roll over, rather than many of the times you see these wide water plane, wide beam boats that I've seen in the past that lose their keels out in the ocean where they're racing or sailing. And they actually basically just sit on top of the deck. And there's no way at all that they can self-right, no matter how much weight you put into it. It's basically like a catamaran. Once you turn a catamaran upside down, it's very hard to right that boat.
Right.
But the upper shape of the hull of the Wave Rover 6.50 will allow that to come back on its own.
So following up on the hull shape, so would you describe this hull shape as a Sharpie inspired hull? And can you explain what that is? And what are the pros and cons of that shape of hull?
Yes, it is a Sharpie variant. Sharpie basically means a hard chine type of construction, more so than a rounded soft bilge boat. And it comes from a day where building compound curves into a hull were not possible because of the material that was available and also the construction tools that were available. They were very limited in how they could shape a piece of wood. People probably remember or hear about how wood was steamed to be able to put it into shape, to be able to fit it into certain surfaces. It's this type of construction provides a very easy way for a backyard builder to assemble a boat, and you don't have to worry about a lot about fairing. Pretty much the surfaces come out fair because they are flat. It's just a very simple, easy way, and I think people, once they start building a Wave Rover, they will enjoy that we made it easy for them and rather than difficult.
Excellent. Now, this is a fairly straightforward question. What is the preferred angle for efficient sailing of this kind of hull?
On a flat surface boat such as this, which has the Sharpie hull, you do not want a large angle of heel. Although you can sail the boat that way, it's not very comfortable. Typically, 10 to 15 degrees is a preferred sailing angle for this type of boat. And with the junk rig, that actually helps quite a bit because, as you mentioned earlier, this could be adjusted depending on the wind speed, wind strength. It's a very straightforward rig. You can pull panels down very quickly, and it will keep that angle of heel at the same angle all throughout the wind range up until the point where you have to completely bring your sail down because you have very high winds. But the other advantage with the junk rig on this type of hull is that because of the shape of the junk rig, as you bring down each panel, the center of gravity of the sail plan does not change forward or aft. It comes up and down, but it does not go forward or aft. So that allows you to keep a very balanced helm. With this being balanced throughout the range, it also makes the use of your Mark III steering system, self-steering system, very easy. You don't have to worry about changing your panels out, and it'll keep you tracking all throughout your wind range.
That's just, that's perfect. That the balance doesn't change as you start reefing. That's such a big plus. The next question, another fairly easy one, really, is what is your designed hull speed with the 650? And I think what the question is really driving at is what horsepower of outboard will be necessary to get to that hull speed?
Yeah, the theoretical hull speed at this moment is approximately 6 knots. The initial calculations I've done show it being at 6.1, so I can report it as being a 6 knot hull speed, which is fairly good on a boat this size. Selection of an outboard for for the boat is going to be up to the individual user. Initially, we're not actually presenting or offering part of that as the package. That'll be picked by the actual owner. But we're looking at potentially boats or engines in the size of 2 to 4 horsepower, no more than 4 horsepower. And you and I have talked both about whether it's gasoline powered or maybe electric powered. And again, that's all going to be up to the user. 4 horsepower will move the boat at about 6 knots in light conditions.
And the way I look at that really is the motor is really just an auxiliary. It's a sailboat, and I'm only using the outboard for the last mile or two, to get into a tight marina or something like that. So that's why I'm leaning, I'm more or less going to say I'm 100% convinced I want to go with an electric outboard in this case. So the next question is, it's a question that a lot of people have been interested in. It's one of the big ones, the bilge keel. So in our case here, we've made it clear we're going with the bilge keel. Can you explain how the bilge keel design dampens the rolling at sea, and how does it improve tracking? And tracking is so important to me because of the self-steering. So go ahead, Andy. What do you think?
Bilge keels have been used by many people for years, for decades, including warships, Navy ships. Before they came out with fin stabilizers, active fin stabilizers, bilge keels were even used on the older, large sailing vessels. They keep the boat tracking. As the boat heels, they keep the boat from rolling back on itself. And having one on each side, in our case, like we're doing, there's other advantages than just keeping it tracking and preventing roll. The other advantage is with the twin keels, we can use those as supports for the vessel, for the boat, when we're looking to redo the bottom on a regular basis. We don't have to come into a marina, be lifted up, put on dry land. In areas where the tide goes out, fairly deeply, we could put it on the beach and let the tide go out and redo the bottom. But the keels, at the angle they're situated on the Wave Rover, with that 10 to 15 degree proper sailing angle we talked about, they are offset at that angle, so that when the boat is heeled at 10 to 15, the port or the starboard keel is aligned so it's vertical, which will help performance greatly.
That's great. Yeah, exactly. Now, the keels, like I said, there's a lot of interest. So people want to know Are they going to be hydrodynamically shaped, or are they just going to be flat plate? And maybe you can tell us what the pros and cons of either one of those are. And well, I'll let the cat out of the bag. They're going to be hydrodynamically shaped. So can you explain how we're going to get the hydrodynamic shape and still keep these keels light where they need to be light and ballast down low where it needs to be?
Yes. Yeah, this is something that I pushed very hard on, was to make them hydrodynamic in shape rather than just a flat plate. You and I had a number of discussions on that topic, and I'm glad I won out. Thank you. The keels will have a shape. They will be built out of steel plate for sure, to give them strength and rigidity. We will lighten them up on the steel side structurally so that when we're placing the ballast, we can place as much of the ballast as low as possible to be able to support the heeling and the sailing capability. They will be shaped using foam, just regular foam that will be fiberglassed over. There'll be a grid pattern, and then the entire keel will be fiberglassed. So it'll be a consistent shape and surface. These keels will be bolted to the bottom of the hull through the double 3/8 ply that we talked about earlier, and through the support structure that will be supporting the bottom of the boat. Shape we're still working on a little bit. We have a generic shape that we started with, but we're going to fine tune that in the next few weeks to come up with the final shape.
So Andy said that he's happy that he won this one, but I can honestly say that in this case, when Andy won, we all won, because I wanted something that was really easy to build, and that's why I was thinking a flat plate would be maybe the easiest thing. But what Andy's describing, what we've been talking about, is still going to be easy to build, and yet a far more elegant solution to the whole problem. And that's why you want to work with a naval architect. And thanks very much for that, Andy. The last question is sort of a curveball question, and that is, what has it been like to work with me on the 650?
As with every owner I've worked with, there are interesting aspects. Trying to take your concept of what you would like to see in a boat, the features you'd like to see in a boat, and to make them come to life, based on making sure you meet certain technical requirements. It's nice to be able to want to have a certain feature, but if you can't do it because there's a technical requirement from a strength or a capability standpoint, you have to make some compromises. But I have found in the various projects I've worked on, the owner's requirements can eventually be met, and maybe not initially how they thought, but they come to an agreement, and we get to a point where the boat does meet the capabilities that the owner is looking for, and it provides a boat that's safe and strong and able to meet its intended use. So far, it's been a pleasure working with you on the Wave Rover 650, and I know we've got a few more things to get through before we finalize to a full construction set of plans. But I don't see any hurdles that we need to, that are going to be a problem that we need to get through to get us to that point.
Well, that's it for the questions. And I'd just like to thank Andy for making the time available to meet with us this morning and, answer the questions. Thanks very much, Andy. And I hope you know that we're probably going to get you back on here at some time in the future to do a little bit more explaining as required. But for now, thank you.
Thank you very much.
Now, in the next video, let the building begin. I'll be ordering up the material and I'll be building the strongback. A great big thank you to the following 3 people who've made a $100 PayPal donation to Wave Rover: Anna Zerth, Phil Johnson, and Sid M. Allen. Their names will be joining the others on the bulkhead and traveling with me on the circumnavigation. I'd also like to thank our new patrons, Edmund Vonderberg and Dr. John Ashfield. These patrons, along with the many others, help to keep the whole program moving forward. So many, many thanks. As always, Rovers, thanks for watching.